So welcome to the first tutorial of Mini Gateways 2022. Really happy to see that so many of you showed up. I'm Sandra Gesing. I'm from the University of Illinois, Chicago at the Discovery Partners Institute, and I'm a co-PI also of Science Gateways Community Institute. And so it's my pleasure to introduce Vasiliadis and Leigh Noble, and who are presenting the tutorial of Globus Online. And so this is a very interactive and hands-on session. I just give it to both of them.
Thank you, Sandra. Thanks, everybody, for joining. Sandra said I'm Vasiliadis at the University of Chicago. And there's a couple of my colleagues on the line also, Leigh Noble and Steve Tarosky, and I thought I saw Nick Saint as well. We are here to hopefully share some pretty cool things. Most of the session is going to be hands-on, doing, installing, deploying, testing, tweaking, so you can actually have a meaningful outcome where you see something actually working, and actually it will be code that perhaps if you're in the process of building a science gateway or a portal, and I'll use those terms interchangeably, by the way, sort of thinking about it as sort of a web app for research. You should have a pretty good head start here. I've had this slide up for a little bit. If you haven't gone to that bit.ly link, please do so if you'd like to follow along. There is actually, let me pull that up so that people can set it up now before I start doing the hands-on things. It'll take you to this page here, and most importantly, the slides are not there yet. I will add them after the session. But this link here there's a Google spreadsheet link behind this that gives you access to an instance, a VM that you can use, that we'll use for the exercises. So if you type your name and email, the DNS name will actually show up here, not the IP address, but and that will be your instance for the whole 3 hours. And actually, I leave these running for another couple days. So if you do start working on them and feel like you want to go back and dig into things some more, which we obviously encourage, they will be available to you. And we thank Amazon for their generosity. So that's the one bit of housekeeping. And then there's other links that we'll be using. In particular, there's a link down here that says Portal Deployment Exercise. That has a bunch of files that have commands, sequences of commands and things that we're going to run, as well as files, code, snippets that we're going to sort of modify as we go along. So I'll bring this up again, but if you want to set that up now and have those windows open, that would be great. Okay, so let's jump in here. The title is Advanced Computing Meets Data Fairness. And really, the reason we titled it that way is because we're starting to see these two things coming together very naturally in the context of science gateways. So whereas gateways used to be really originally about sort of job submission or access to compute resources and running things in different places, they've increasingly morphed into something broader, in particular something that enables data access as much as it does compute access, and increasingly have added more sophisticated capabilities, both on the compute and the data side. So we've started to see people building these over time. Obviously, the SGCI is testament to the fact that these are very important sort of artifacts and things that are then tools that are needed. So hopefully what we'll do here today is share at least some of our perspectives on how to do this. So here's an outline of the session. I'm going to spend a little bit of time just talking about the motivation for some of the services and tools that we're going to demonstrate and work with. I'm going to introduce the modern research data portal design pattern, which some of you may already be familiar with. If so, I apologize. This will be a bit of a repetition, but I think it's kind of fundamental to building these kinds of applications in a way that's scalable and serves users as well as possible. And then we'll increasingly go into a bunch of hands-on exercises where we'll actually deploy a portal using a framework that we've adapted, which is based on the Django Python framework, and we'll sort of go from there. So without further ado, let's jump in. And please, by all means, feel free to interrupt me, unmute yourself and ask a question. I think it's much more useful if you sort of catch me in the middle of something and I can explain it, or we can, go down whatever path you like. I do have the chat up, but I may not be able to see that all the time. I'm going to ask Leigh and Steve to sort of monitor that and either address questions or sort of interrupt me and say them out loud so we can discuss them. Oops, what's going on here? That's bizarre. Okay, sorry about that. So really where a lot of this originated for us is we've dealt over the years as a group with many large projects, and increasingly those projects have involved working with some type of light source, be it an accelerator of some type, increasingly cryo-EM, which I'm sure many of you have at your institutions. So the light instrument problem is the one that's been driving a lot of what we've developed over the last couple of years. And it's really as a result of this curve here. So you've seen Moore's law, you've seen the genome sequencing, all the wonderful hockey stick or exponential curves. Well, this is the brilliance arms race. So this is showing the intensity of the light sources over the various generations. And you can see here the timeline, how in sort of 4 decades, we've gone many orders of magnitudes sort of brighter. And what that really means for us as people that are supporting research done with these light sources is basically more data, much more data at much higher velocities, and data that's also going to more and more heterogeneous computing sources, storage systems, obviously, with object stores and various tiers of storage in the mix nowadays being very commonplace, and increasingly complex workflows because of the nature of the research. The experiments themselves are getting more complex, more interesting. So all of these things are really what's driving the need for these types of solutions. And this is, on this slide here, I'm going to show a flow that is sort of a very common pattern. This is actually reflecting one of the beam lines at the advanced photon source, but it's really sort of, you can easily generalize it to many types of instruments. And the flow goes something like this, right? So you have an instrument that's generating data. Let's say for this argument of this discussion here that it's some kind of imaging system. You have something that captures the data very close to the machine, to the instrument itself. You have to get that data somewhere to compute on it, do image recomposition. Maybe you're doing some kind of 3D rendering, what have you, other sorts of things. And then your data products, if you will, from those analyses are things that you want to share more broadly with collaborators, initially perhaps with just your project, but potentially in many cases much more broadly, and certainly once you've published, you want to make those data available. and typically you want to put them somewhere where they can be searched for and discovered by others. Of course, there are cases where you don't want that. If it's protected data, you want the appropriate controls in place. Both of those use cases and sort of the continuum between those are things that are very important, and we've thought very long and hard about and have some thoughts on how to address. And hopefully, if you have this kind of infrastructure in place, science happens. Okay, so there we go. So I'm going to touch on a few of these services. This is sort of the collection of things that come together to deliver this more robust, full-featured capability. I'm not going to spend time on this slide, but that's just sort of a snapshot. We're going to dive into just a couple of these in more detail. There's obviously a lot more that we could talk about, but we only have a couple, 3 hours here. And a lot of this material has come from engaging with an increasing base of researchers, administrators, research computing leaders around the world that use Globus, that use the Globus platform, and are increasingly building these kinds of tools on top of it. So to set the stage for what we're going to actually work on, I want to introduce this design pattern called the Modern Research Data Portal. So this is something that was developed jointly by the folks at ESNet out at Berkeley Lab and some of the folks from the University of Chicago. And I've got you can see the citation down there. If you go to this link, you'll see a collection of materials, both the original paper as well as an example of the portal that's running. But the key point behind this design pattern is, I'll break it down architecturally, but the idea is that we want to ensure a number of things. And I'm going to actually sort of go from the middle, because one of the key things when you're dealing with instruments is that in many cases, the experiments can't be replicated. So you need to capture the data and do something with it and make sure that you do it relatively quickly, because these are shared expensive resources. And so rapid, reliable processing, movement, replication, etc., cataloging of data so you can move on to the next thing, or the next group can come along and use the instrument are kind of critical. I mentioned security, so being able to ensure that you've got the right level of access control, all the way from open public data down to very sensitive, protected data with perhaps personal health information, what have you. But overall, the idea here is to make the data more fair, more findable, more accessible, interoperable, and reusable. We really focus more on the F and the A in that acronym, and that's certainly the focus of this talk. This is not so much about interoperability and reuse, because the I and the R can't happen unless the F and the A happen efficiently and effectively. So, what are the benefits of using a science gateway or a portal such as we're going to describe here? So it does make the data fairer, because firstly, it's a place where you can go and search and find the data. And it does make it more accessible because of the architecture that allows you to get to the data faster and put it places where you can do something useful with it. The other thing is that you can actually deal with heterogeneity. So, building a solution for a single experiment is interesting and useful, obviously, but arguably, if you have much more broad efforts where you're dealing with different types of research, where the nature of the research is evolving, and along with the makeup of the data and the compute experiments and so on are changing, you would like to have something that can sort of handle all of that increasing diversity. You also want to make it easy for people to discover we're all very obviously accustomed to just, Googling or searching with your search engine of choice and finding things. And there are many other search services, that are more sort of discipline specific or purpose built. This is one such idea, is that you have a search capability that is designed for finding data products in the course of research. I guess I mentioned access control. We are going to talk much more about that. The other nice thing about this portal structure is that it integrates with the very many Globus services that are out there, and that's useful because as I said, we have a very large install base, and many research institutions already have their storage accessible via Globus. So you can sort of layer these kinds of solutions on top of that and take advantage of that infrastructure that's already been put in place and is being used probably in a much more ad hoc manner right now. Okay, so let's talk about the elements that go into this modern research data portal. So the gray boxes at the top, sort of the hard infrastructure. So on the left, you've got the networking side, the science DMZ. I'll show a couple slides on that in a little bit. And within the science DMZ, you're running data transfer nodes, which are these servers that are really designed specifically for moving data around at high speed and doing so reliably. And then underneath that, you've got perhaps that should be the other way around, but you've got a number of software pieces. The one is Globus Connect, which is the thing that allows storage systems to be accessible via Globus. And then we have the Globus platform that delivers these various services with different access modalities, the web, command line, and the API, which is really what we're going to use today. And so bringing those together in the form of a framework that allows you to build discipline-specific or project-specific logic, that in totality is sort of what the design pattern is about. So I mentioned Globus Connect. That's the way you connect to storage systems. We have a number of connectors, and this list grows over the course of time. We just added Microsoft Azure Blob storage support a few months ago. That's the most recent one. So you should be able to talk to practically any system that you might have access to. So I'm sort of pushing this idea of this modern, quote unquote, modern research data portal. So you may be wondering what's wrong with your LRDP, the legacy research data portal. So I forget who first shared this quote with me, but I thought this was very apropos, right? If you've been doing the same thing the same way you've been doing it for 10 years, chances are you're doing it wrong. And many of the portals, if we can call them that, or science gateways or web apps that are running today that have been around for that long a time are certainly due for a refresh, so they can take advantage of many of the new innovative capabilities that are out there. And the legacy architecture typically looks something like this. You've got your portal, as well as all your data. Everything is kind of munched together and sits here on the bottom right behind enterprise firewalls. And so this red path is one that sort of has very stateful packet inspection kind of stuff in the mix, and is really typically carrying all sorts of traffic, all the way from phone and email and who knows what else, and streaming video for all the students on campus, right? So you've got sort of enterprise traffic, as you would expect. It's an enterprise network, and it's certainly not tuned or optimized for moving research data, which has a very sort of specific profile. So the science DMZ architecture at a high level looks like this. And the key point here is that we separate out we create a separate clean data path for research data to flow. That's the paths in green. The portal or the application logic, if you will, still resides behind the firewall. And that's actually fine, because certainly the level of the volume of data or the level of traffic that goes to that is relatively small. The bulk of the bandwidth is being used here on this green path. And so this is what a lot of institutions have put in place over the last 5 or 6 years. And the one thing that I will point out, because we always get questioned about this, which is that this looks very insecure, because suddenly we're not behind all these nice devices that keep us safe. This red path, and the reality is that this model is actually just as secure if you configure it correctly. If you only send the right type of traffic over this path. So this is not intended to be an alternative path for all your network traffic. This is intended expressly to be a path for certain types of traffic, in particular, in this case, data channel traffic over the grid FTP data channel, which is what Globus uses for managed file transfer. So hopefully, for those of you that already have this, I apologize if I've bored you, but I think it's really, really important to be aware of this, because if you go out and build cool solutions like the things we're going to show you today and deploy them with the sort of the old red line model, I think you'll have some disappointed users, and you'll probably be disappointed too. Okay, so with that said, I'm gonna quickly pop over and show you, whoops, sorry, my mouse has a mind of its own. I'm gonna show you an example of one of these things, and I like it mostly because it's got a cool name. As you saw here, it's the AC/DC, the ALCF Community Data Commons. I'm sure Lee or others can correct me. We'll know, ALCF Community Data Column. Never mind, column. Okay, so this is an example of it's Science Gateway / Data Portal that was built by a combination of the Argonne and the University of Chicago teams, the Globus folks, mostly in the context, as you can see here, of supporting beamline science on the advanced photon source, but also to support some other very different use cases. So this, to my point earlier about having a solution in place that can address data heterogeneity, here you've got, what are these, 1, 2, 3, so sort of 5, the 5 here, except the one at 6 o'clock, are beamline projects, I believe. And then this one here is Materials Data Facility, which is actually a repository for materials science data sets. It's a sort of a curated collection of data sets from all over the world, actually, that are sort of being brought together by the team at Argonne and made available to the materials characterization folks. And then on the top right here is another one that's the DL Hubs, that's a deep learning hub. So this is a repository for machine learning models that can be, you can register them, you can publish them, the people can discover them, they can use them directly through the hub in some cases. So again, very different use case than some of these others, which are more about that flow that I showed earlier, which is getting data off an instrument, doing some type of analysis, processing, and then describing the products and making them available for downstream discovery. So I'll show you what one of these looks like. I'll pick on the public one so I don't have to go to show private results. So this is that materials science data repository. And you can see here sort of a classic faceted search screen. Think, Amazon shopping or whatever. So initially you land on the page and you're seeing almost 1 million or so records that have been amassed in this collection. You can increasingly narrow down your selection by deciding, you want to see ones that are tagged in a certain way, that came out of a certain organization, and so on, published in a certain year. So you can progressively narrow down your results. And as you can see here, the facets are specific to material science. And that's one of the nice things about this framework, is that you can define the index to include whatever attributes, whatever metadata and facets that are relevant to you, to your project, to the community. If you have standard schemas and ontologies, you can reflect those here. I'll talk more about how the search service actually is put together later on, but you can see that reflected here. And so I can look for data, and then when I find something that I like, perhaps I want to look into it a little more and make sure that it is what I'm looking for. And this is an interesting view here, because this has additional sort of related data sets that have been discovered by various means. One of them here I see is the Collaboratory, which is a machine learning powered discovery service. So that's, I can sort of confirm that this is what I am looking for. And then when I click the Get the Data button, I get dropped into Globus. I can log in and go and access that data and move it and do something else with it, perhaps. So that is just a quick overview of one such solution. As I said, this is something that we have been working on for a while, as you can see by the various different projects that are already supported. But you can get something like this up and running today. And that's actually the objective of today's session, believe it or not. You'll be able to walk away with something that looks very much like that. And if I can get slides back. Okay, so actually let me pause there. I've been rambling for a good long while. Let me just pause there and see if there are questions. Anything, just feel free to unmute or put something in the chat. I'm looking at the chat. Nothing there other than administrative stuff. Okay. All right, good. So this is mostly introductory, so I don't expect anything untoward. Okay, so let's dive in. So I'm going to talk about some of the platform services, if I can get my mouse to work again. Sorry, I'm not sure what's going on here. Okay, so this is sort of a stylized view of the main services that are currently available on the Globus platform. The transfer service, sort of top left, that's the core, supported by the auth service for authentication access control. And then the other services are ones that we're going to dig into in a bit more detail. But for building these types of science gateways to support these flows, these data flows for instruments and similar environments, these are the four sort of core capabilities that we think need to be brought together. So there's obviously a need to move and share data, both between systems and people, and between the instruments and what have you. But very importantly, there's a need to describe the data and make it findable, right? We talked about that, and we'll continue to push on that. And then at some point in the flow, there's always a need to compute something, and being able to orchestrate all of that in conjunction with having the data where it should be at the time that it's needed and so on is kind of key. And again, underpinning all of this, you need some capability to check who can do what, where, who can access what, and who can share what with whom, and so on. So all those different types of access controls, actually at a very, very fine-grained level, are things that are handled by the platform and are actually very, very critical to the overall solution. So I'll start out by talking about that, because that's really the foundational piece, this Globus Auth service. So what is Auth? It's a broker of authentication and authorization transactions, if you will, amongst various entities. So we've got a whole bunch listed here. We may typically think of authorization and authentication as being a user trying to access a system, and once they've authenticated, determining what functions they have access to. But it can equally be between different services. So if you have a service architecture, or you have an application that needs to call out to other services, you can use something like Globus Auth to broker the getting credentials and making, keeping those current, and making sure that the resources on those external services are accessed with the proper protections in place. This is, if you're familiar with OAuth, the OAuth protocol, this is really all standard OAuth. We haven't done anything bizarre or proprietary here at all. So it uses OAuth, and then in conjunction with that is the OpenID Connect, or OIDC standard, that's used for talking to identity providers. And actually, I will say the one thing we have done is we've actually added to, or sort of enhanced the standard by adding something called dependent service tokens. That's outside the scope of this talk, but if you are in the business of building larger scale systems with multiple services, that's actually a very, very useful feature. But other than that, I mean, this is already pretty standard. If you know OAuth, you know it all already. And if you don't, I will touch on a couple of key points. I'm not going to go into OAuth because it can be quite a bear if you've seen it for the first time. But mostly for our purposes, I want to talk about the types of use cases that we use Globus Auth for. So the one use case, as I just mentioned, is the application needs to take an action on behalf of the user. So the user has to grant their consent so the application can do something. So that's pretty standard. If you've seen consent screens, which you probably have if you've logged in with your Google account on some other service, or with your whatever account, you will have seen those things that say, this application wants to do A, B, C, and D. Do you consent? Yes or no? So that's the idea here. The other case, as I said, is that the application itself may actually need to do something of its own accord. So it might have some housekeeping that it needs to do that's not specific to a user session. So if it needs to reach out and do that, it can actually act as itself, as a sort of a first-class entity, if you will, in this ecosystem. And I like to use this phrase that apps and apps are people too. App are people too. Okay, typo there. But every application that's registered with Globus Auth, every client in OAuth terminology, has its own client identity, which is just the same as me accessing the system with my identity as Vas at UChicago, or whatever identity from some identity provider. And then the other thing that's useful, there is an aspect of the OAuth service that's called refresh tokens. So this is something that makes it possible to have long-running unattended processes and systems. So if you sort of kickstart the process by getting the initial set of credentials, but along with those credentials come a related set of credentials that are used to refresh and keep those the main credentials, the access credentials, evergreen. So that flow is kind of built into the standard, and we support that, so that in a lot of cases we have processes or applications or scripts that are running unattended for extended periods, and you obviously don't want to have things time out and you have to go re-authenticate. You just want them to run kind of lights out. So that's very handy for those kinds of use cases. Okay. Then, of course, data transfer and sharing. I won't talk too much about this. I mean, that's the core of the platform. Hopefully, some of you have used Globus to move data around. Perhaps you also use it to share data with someone outside of your institution. But the key point here is this idea of using the sharing capability, the thing we call guest collections, to make data accessible to a broader audience with controls that are implemented and enforced by the Science Gateway or the web application itself. And typically those access controls are enforced on groups of people, because you most often will have many users, and you want to structure them in some way such that you're not dealing with permissions on a user by user basis. So having access to this group service, and then this fine-grained access control through the Globus guest collections, those two things work, they sort of complement each other to make some of this stuff a lot easier to build. Because basically what it means is that you don't have to have local accounts. You don't have to maintain your own usernames and passwords for every little app, for everything that the user has to do. You can basically rely on identities flowing through Globus Auth. And when you're actually touching resources, in this case, storage, data resources, you don't have to worry about, mapping to local users. You don't have to create like 1,000 temporary users on your storage system, for example, if you want to publish some data. So, and then just to sort of go down to the next level of detail on that, there is one sort of priming the pump here, which is you have to create the guest collection manually. So this is not a fully automated process, but once you've created the guest collection, in other words, once you've made it possible for data to be shared off a system using sort of the Globus credentials, then all the rest of that can be handled in an automated fashion. The turning on and off of permissions, the adding people to groups and removing them from groups to grant them or revoke access, all those kinds of things happen automatically, or they can be automated directly through the Science Gateway. The one other aspect that's important here is that your application must or should have this access manager role. So when we talk about these guest collections, the way we share data, you can set different roles for people to access them, all the way from the administrator down to manager, monitor, etc. But there's this specific type of role for these guest collection, which is called the access manager. And as the name suggests, it's a way to delegate access control management to something else, in this case, the application. So by virtue of granting the application the access manager role, it acts, again, just like a person, like the administrator, who is deciding to give write access here or give read access there or whatever, except that's all done now through code, and can be done on the fly when new users show up or after they're approved or whatever. And here in the second sub bullet is when I was talking about the application acting on its own, as itself rather. It uses its client ID. That's its own identity within the Globus Auth service, and that's how it's sort of uniquely identified, and it has a corresponding pair of credentials that it uses to access, to authenticate and validate and get tokens from the service.
Yes, can I interrupt for just a second?
Yeah, please do.
I just wanted to let people know that client identity might look unfamiliar to you, but anybody who registers an application to be used with Globus gets this. It's something that you automatically get when you register an application to be used with Globus. And so if you have never registered an application, it might look unfamiliar to you, but we're going to show you, Vas will show you in the demonstrations and examples how you do that registration, and you'll see where you get your client identity.
Yep. Yeah, we are indeed going to register, and you will have your very own app client ID shortly. Okay, any questions on that so far? I know I've thrown quite a bit of stuff at you, especially if you're not sort of up on OAuth and security bits, but yeah, that stuff's obviously pretty foundational. So I feel like you have to be aware of it. You can dig into it. Yeah.
And the other side of that, is that the way that it's been presented so far is pretty theoretical, and it'll all make sense when you actually see it in practice in a few minutes.
Yes.
It's actually much simpler than it sounds.
Yeah, actually, that's a good point. I mean, just that sort of more generally speaking, a big part of the motivation for having these services is such that they abstract away or they shield the user from the complexity. And the user in this case is not just the end user, but it's also the developer. So there's a lot of tools and machinery in place where you can just, call things and lots of magic happens behind the scenes. Okay, so I'm going to walk through just a few more slides here that to talk specifically about the data portal framework. And so this is something that has evolved. So I talked about the modern research data portal. So we had an initial implementation of that as part of that initial publication, like 5 years ago now, and that was a Flask-based Python Flask framework-based application, and really it was built more as a didactic tool, right, to help people understand and walk through, sort of more educational type scenarios. And at the time, we didn't really have search and some of these other services, but once search sort of matured and came to be the service it is today, bringing that into the portal is what really made it much more useful and really started addressing the findability and accessibility aspects. And then since that time, we've also added these things called flows, which I'll talk about towards the end, depending how much time we have. So this becomes now the portal frameworks that has all these different components in it, or at least the potential to access many of these components, but search is sort of integral to it. So that's why I'm going to spend quite a bit of time talking about search, and we're actually going to work with it a little bit today as well. But here are the core functions that you get in this Django framework. So the user authentication is built in, so you can take advantage of the federated login, for instance, that's there, and you get access to the user's identity, and you can do all sorts of useful things, as far as perhaps maintaining user profiles for your own, custom purposes and so on. The framework is based on Django, so that's for those not familiar with that are not from Python backgrounds. That's a very widely deployed and used framework for building applications. It's sort of it's referred to as batteries included, meaning that it does tend to be a little more heavyweight, but that's because it provides a lot of the various pieces like, object relational mapping, services and things like that, all sort of out of the box, so that you have to build very little to get up and running. And that's one of the reasons we use it, even though we don't necessarily use the ORM much. Maybe we do, Stephen can correct me. But we took that approach, both because there's so much install base out there and lots of support available, but also because it lets you get up and running pretty quickly. So the framework is there. There's a service, the service calls out to Globus Search, and then there are some sort of internal flows built into the app that manage the request response lifecycle. So that's all stuff that almost every framework gives you, but it's there. And in this case, it's done in the context of the various Globus platform services. So in particular, you have things like access tokens and that being passed around, and you have marshalling of requests and so on, transparently to you. So you can just say, create a search index, or push this into the search index, or find me this, and it just gets done. All the authentication is handled automatically and all that. It's pretty cool. Yeah, speaking of authentication, I probably should have talked a little about scopes. I think I have a slide later on for scopes, which doesn't help us here, but a key aspect of the OAuth standard is this idea of scopes. So scopes determine what specific functionality you have access to against a resource, again, in a service, let's say. So an example of a scope might mean, as you can see down here, there's some examples of scopes. So the bottom one is I can view my groups and memberships. So I can only view the ones that scope only allows me to see the groups that I'm a member of. Perhaps someone who has more access would be able to see all groups that are available in the system, or that are publicly visible, what have you. So what happens is when you request access tokens from Globus Auth, you tell it what you intend to do with those tokens, and you get back tokens that have these scopes built into them, so that when the application turns around and uses them, it's that access is available. And if it tries to do something that's outside of these scopes, then the request will be denied. There's this thing called Python Social Auth that we leverage. It's a library that's very widely used for doing this kind of federated authentication through the various social network IDPs. Whoops, sorry about that. I think I was going backwards. Actually, all of this gets done using the Globus SDK. So we have, as part of the platform, a Python SDK. You can, when you talk to all of these APIs that we're going to work with today, you can actually use low-level calls. So you can do straight, gets and posts and puts and what have you. But for the most part, certainly when you're talking to the main Globus services, we've wrapped those in higher level functions, so that you don't have to deal again with things like marshalling and serializing responses and things like that, and objects and so on. So the calls use the Globus SDK. The portal, the Science Gateway, gets a token or a set of tokens, access tokens, from Globus Auth, and then depending on what it needs to do, so let's say it needs to grab some results from a search index, it will go to the search service with the appropriate access token. It will make the request, assuming it has access to that index and that data. The response will come back, and then the portal will render that on the web page using some type of template that you have provided. And as part of the framework, we've provided some very sort of basic templates, but I think they're nice and clean and useful. They're very similar actually to what I showed you earlier on that AC/DC portal. So you can start with that, and of course it's really up to you as far as how much you customize it and what you do with it beyond that. Okay, so I'm not going to spend too much time on this. So, well, actually, I'll talk about the first bullet because that's important. So we're gonna see 3 different pages, and these are the 3 URLs. So the first one is sort of the high levels, like that landing page that you saw, where we decide which index we're going to go against. So you saw the 6 or 7 projects that were there. Each one of those has its own index, its own data, obviously behind the scenes. So that's the one sort of landing page, if you will. Then for each of those, there's that index search page. That's the one that I showed you for the materials data that we were filtering up and down. And then when I clicked on the specific datum, it took me into a details page. So that sort of hierarchy, if you will, is something that's there, and you can just use it as is, or just plug in your own index. And we're going to do that in a real example here in just a little bit. Let's see. Oh yes. So I'm going to talk more about search later, but the key point about search is that you can have multiple entries that resolve to a given subject, as it's called. So you have this piece of data, this file, this URL. It's a unique URL. You can get access to as part of search results by multiple entries, as we call them in search. So you can create these different indexes, but that subject can only appear once in an index, but it can have multiple entries associated with it. This is how URLs look. This is standard Django stuff. If you're not familiar with it, you obviously look at the documentation. The one thing I do want to talk briefly about, because we're actually going to do this sort of after the break probably, is configuring the index. So we've packaged this really, really nicely such that you can set up that faceted search just by specifying a handful of fields in the configuration file. So we have it broken out. There's a file that's specific to defining the search index, or the set of search indexes that you want to see on your landing page, and then hence downstream from there. Each one of those indexes has a UUID. That's how it's uniquely identified within the Globus search service. So when you want to use this portal, so we have one created. Actually, I have a couple that we're going to use today, but there's one that's sort of the default one that shows up so that you can actually have something usable straight out the box, so to speak. But presumably you would want to replace that with your index once you create that. And so you define, you tell it which index you want it to point at, and then you define the names of the fields, and then the facets that will be used for doing that search, the sort of narrowing and broadening the search on the left there. So that's really all you'll see. This is the layout, to just basically a JSON structure, and we'll dig into that in just a bit. Skip that. So I want to actually get to doing something. So we are right at the top of the hour, which is great. So so the first thing we're going to do is actually deploy one of these, and hopefully you'll see how relatively easy it is to get it up and running without really any coding, so to speak. So and thanks to Steve and to Nick on our team, who were the masterminds behind this. So so I'm going to click off here. Oops. By the way, if you don't have that link by now, you go to it. If you want to follow along, and you can grab a server, there's a link to that spreadsheet there. So assuming you have your server and you want to follow along, so I'm going to go through this fairly slowly and give you time to do it yourself, and hopefully you'll ask questions along the way. And if you have questions about what's going on, if something isn't working, would like to, hopefully work with you here live to resolve it, so we don't leave anybody behind. And we've got enough people that if you want to fire away in the chat, or you want to just raise your hand or unmute and ask the question, we'll address it right there and then. Okay, so let's see. Here's what I'm going to do. I'm going to go and get my instance. So here's that spreadsheet. So as you can see, this is very creatively numbered. Tut tutorial, and then a number, and then .globusdemo.org. And for all of these, we're going to use just this. There's multiple local accounts provisioned on these machines, on these VMs. We're only going to use the dev account because that also has sudo privileges. Yeah, we don't really need those, but so we're going to log into the instance as devn at tutn.globusdemo.org. And the password is, I'll put it, someone deleted my title up there, but that's okay. The password is, where should I put it? Actually, I'll put it up here. Globus _2022 pound. Actually, I should probably put it in the chat. I don't know which is less secure. So that's the password. Okay, and so I'm going to go in and shell into that instance. Let me know if that isn't big enough. Actually, I'll make it a little bigger. So I am dev1 at tut1.globusdemo.org. Okay, Globus _.
Wes, you wanted to send the password to everyone, huh?
I sent it only to you.
Yeah, I sent it to everyone. It's okay.
Sorry, I didn't realize.
I have the secret password. Sorry.
Yeah, that's Sandra's password. Don't share that one. All right. So here we are. This is Ubuntu. Your distribution may vary. That's quite fine. We don't care. This is all Python. The other thing I'm going to pull up here and sort of actually keep these side by side. Let me put this window over here. And then I'm going to go to this repo here. So if you go to that bit.ly link, you land on this page. So click on this link, which takes you to my very own VAS tutorials repo. And this is really just so I don't have to sit and remember what commands to type and make mistakes, because some of them are pretty lengthy. So the first thing we're going to do before we start running code or anything is what Leigh mentioned earlier. We're going to go and register a Globus auth client, as it says here. So we're going to go to developers.globus.org. So I'm going to click that. And we're going to register our app with Globus. Okay. And if you have an identity from one of the, 1,500 or so identity providers, if you've never used Globus, you can just log in with that. It just works. Otherwise, you can log in with your Google account, or you can go and create a Globus ID, which is our own username and password. We sort of tend to discourage that because we don't want to be in the business of managing people's credentials, but any of those ways to get in works. I will actually use that one, having said all that, just because that happens to be my primary one from the beginning of time. So I will log in. And my page will probably look a little different than yours. Yours may be blank. You may be prompted to create a project. A project is nothing more than an organizing construct to allow you to group multiple apps and things and server deployments together. So create a project. I already have many, as you can see. So I'm going to just go into my sample data portal, and then I'm going to click the add button, and we're going to add a new app. So this is what we're doing here again, is we're registering our Science Gateway, our portal application, with the Globus Auth server, so we can use it to get credentials, get tokens, and access other services. Okay, so we're going to give it a name. Let's make this a little bigger. So this is going to be VAS SGCI. I'm going to call it Gateway. Okay, now the only thing that must be provided is this thing here called the redirect URL. And what this is, so the way that, without going into any of the details, the way that the OAuth, the authentication process works is it's a multi-step flow. It's a three-legged flow, as they call it. So what happens is when you try and authenticate with OAuth, you get sent out to your identity provider. Then when you come back, you get, once you're authenticated, then the second part of the flow is to go to the Globus Auth service and present that authenticated user to actually say, give me a code that then I can exchange for tokens. And as part of that flow, the OAuth, Globus Auth, the OAuth server needs to know where to come back to in your application. So this is a URL that's served by your app. It's an endpoint on your application, an HTTPS endpoint specifically. And so it has there's a sort of a common structure here, but we're using a slightly different one, but I've just got to remember what it is. So it's actually, I have it in my slides. I know it's /complete /Globus, I think. Yeah, so I'm going to put this up here, make it a little smaller so I can see it. So you need to put these two URLs. Unfortunately, you don't have the luxury of copying them. You'll have to type them, but I'll give you time. So it's your own subdomain. So in my case, it's tut1. And this is going to run on port 8443 just because running it on proper 443 requires a lot more infrastructure. So we're just keeping it simple for now. So if you're wondering why that's ugly, that wouldn't normally be the case in your own application that's sort of deployed in a production setting. Make sure you have the trailing slashes. As I discovered at some ungodly hour, that makes all the difference between this working and not. Yes, I can paste those. Absolutely. I should probably have put those in my cheat sheet, shouldn't I have? I pasted them in the chat. And actually, while we're about it, because full disclosure, I have another one of these tutorials coming up literally at the tail end of this one. I'll go here. Whoops. Just go and put it in the tutorials repo. Yes, I'll actually, let me just edit it and put it in this file here. So if you go to commands, so this is redirect URLs for Globus Auth client registration. Okay, so we're going to do tut-n and tut-n. Okay. All right, so back to that. So that's all you need to do. Give it a name, that, and then click Create App. See if you need, if you run into issues, please ask. So that should just work.
This is Martin.
Yeah.
Yes, I am having a hard time finding that URL that GitHub that you just showed.
Oh,
those instructions. I missed it somehow. And
yeah. So
could you paste that in the chat too?
yeah, if you go to actually, I can just paste this one directly, but the main it's linked to from the other URL, which is this one here. The bit.ly. It's bit.ly/mini SGCI-2.
I have that one. I'm just getting lost in all those URLs that are in there.
I know. At some point, I'll figure out how to consolidate everything into one. It's just hard to get everything nicely formatted everywhere. Yeah. So if you're on this page, you can get to the repo here.
Yeah. Okay.
I should probably make that more explicit and say that's the GitHub repo. Okay.
Right. So one last thing that I'm still lost is so I am logged into my Globus portal, but I don't know. I missed when you. How do you get to the add part? To
the developers one. So you go to developers.globus.org. And that will land you there, and then click register your app, and then you'll see that screen that I was just on where you can add the client registration.
Okay, good. I think I'm good. Thank you.
Okay. All right, so we registered our client, and this is the client ID that Leigh and I both highlighted extensively earlier. So let me see. Yeah, okay. So Globus Auth uniquely identifies my instance of the portal here that I'm deploying using this client ID. And because this is going to be what's called a confidential client, in other words, the reason it's going to be, it has the ability to keep a secret because it needs a pair of credentials, right? It needs the client ID, which is sort of a public one. If it's not a public one, but it's that's one half of the credential. The other half is a secret key. So I will create that. I will generate that secret, and those two are used together. Every time the application, the gateway is going to make a call to Globus Auth for credentials or for other things. So I'm going to create, I'm going to generate a secret. So this is for SGCI tutorial. Okay. And you may have done this other places. You see it once, you better copy it and put it in a safe place. In our case, we're going to put it into the portal configuration, and that's something that should obviously be properly secured. I'm going to copy that and do something less than secure and just put it in my editor for now, so I don't have to go back and forth. So I will copy that and my client ID. So you will need both of these to deploy the portal as part of our installation script. You're going to be prompted to enter both the client ID and the secret. So I give everyone a minute or so to get those and stash them away somewhere. Okay. All right. Okay, so we've done step 0. 9 more to go. That's not that bad. It's actually pretty quick. I'm belaboring some of these points, but I just want to make sure that I don't leave anybody behind so that you can really get the full benefit of this as we get into more interesting things. So, so we're going to install some software. We're going to basically install the portal framework using this wrapper tool called Cookie Cutter, which I'm not that familiar with, but I've been recently made familiar. This is probably old news to anybody who's used Django before, or so I'm told. So it's a commonly used sort of a wrapper. I don't know what the right word is. Maybe Steve can chime in with a more technical term. That's the way I think of it. So it'll basically create an instance of the Django Globus framework with all the right configurations and all the bits and files in the right place, so that we can literally just go run and it runs. The one thing I will do is we're gonna the code gets deployed in a directory that's named after the project project slug in Django. So I'm just gonna use my name and basically put that in the environment so that I have it. So my portal is just going to be called, actually, let's call it Science Gateway VAS. How's that? Okay, so I will do that because there's a lot of commands where you have to edit files or change things in /portal slug, etc. So they use that. And then we're going to run all of this in a Python virtual env. I've created all of these. That's all been provisioned on the machine already, so you don't have to do anything other than just source it, so that it's activated. So the virtual environment is in .portal and our home directory. So once you activate it, you'll see the prompt change. Again, if you're not Python savvy or familiar with Python, some of the stuff will obviously be a little foreign, but hopefully you could literally just copy paste as we go along here, not really knowing what you're doing, and it should all still work. We've tried to make it fairly robust in that sense. Okay, so once we activated the environment, we're now going to actually install the thing. So run cookie cutter. Okay, and this is where it's going to prompt me now for a number of things. So project name, I'm going to use that same SGVAS throughout, just because it's terse and I can type it quickly. And I'm going to do the same thing here. I'm told this is not convention. I've never been accused of being conventional, so I will be true to that form. As you can see, all of these things have default values, and you're welcome to just accept those. I will just click through all of this for now. Obviously, if you're doing this in a real environment, you would want to put things in place, time zone, etc. Again, I'm not going to spend time talking about these all these variables that you can configure here, because this is fairly standard Django stuff. There's lots of great documentation, and I'd rather focus on the sort of the novel bits. So the one thing we are going to change here is this the Globus the client ID. So that's the thing we just got from registering our application. So I'm going to go to my editor and copy that, and the corresponding secret key. Okay. And then for now, we're going to use the default search index, so we can actually get something up and running right away. And then after the break, we're going to actually break that all up and use a different index, so you can see what goes into changing the index and changing some of the templates. So I'm going to accept that. And that is pretty much it as far as installation. So I'm now going to go into that directory we just created. So what was actually created there, you'll see it created a sort of a top level directory, a project directory that's going to hold, potentially multiple of these apps, but we only have one here. So that's all our code is actually in that one there. But the first stop is here inside the tilde whatever project slug directory initially, because we have to install a couple of libraries that are required for all of this to work. So we've put the code in place. We just need to figure out some of the dependencies. So we'll do a standard pip install. The requirements, by the way, I'll show you that requirements file. It's just a couple, 3 things. I think it's the Django framework and forget what else is there. Oops. Yeah, so, okay. Pretty standard stuff if you're Django. So this is the actual portal framework. So we're pulling that in as part of the installation, in addition to a couple other things. Okay, and now before we do the final config, we have to edit one file. So I've got it here in step 5. So we're going to edit this file here. This is where Django stores all its sort of system-wide, its app-wide settings, hence the name. So the reason we need to do this is this is not something you would typically need to do yourself if you're running it. If you just want to run it locally to build something, this is just some cruft that's there because we're running it on VMs under HTTPS. But in any event, I'm just going to quickly edit that file. So it's in my top level directory in my SGVAS and settings base py. So you can just copy the command. Here's the editor. Okay, so once you get into this file, and please tell me to slow down if you want. I know you can use the little hand gestures. If I'm racing ahead and you're trying to frantically keep up, let me know. I'm going to pause here right after this before I do anything else. So the only thing we're going to do here is go down to this line 42 that says installed apps. And to that list, we're going to add this package or this app called Django extension, Django _ extensions. Okay. Save that. So that's really the only sort of bit of coding config. And as I said, when you're doing it, when you try this at home, you shouldn't need to do that unless you want to go to a production HTTPS setup, and that actually you should use other approaches for that. Okay, so once we've done that, go back to my cheat sheet. Now we're ready to sort of tell Django where everything is going, I guess. Stephen can tell me what I'm actually doing here. Okay, so running migrations. I like when I see all green stuff that says okay. And I'm going to run this collect static, which I presume is to put static things somewhere where they can be served more efficiently. So it copies them to some other directory. And so that's it. So those 3-4 commands and that one edit, and now we can run it.
Hey, boss.
Yeah.
Steve, the migrate command, if you're not familiar with Django, it just sets some initial ORM stuff that is native to Django. So it's just setting up some tables and things like that. This default cookie cutter package is using SQLite. So it's a local database that's setting itself up within the application.
Gotcha. Okay. So this is like migrating like Alembic or that kind of thing, right?
Yeah, and you would presumably create your own models if you needed them, and then run make migrations and migrate, and you would then get your custom models in there.
Gotcha. Okay. Yeah, actually, thank you for clarifying that, because certainly one of the things that we know people do with portals is they have something like a user profile. So even though you're using Globus Auth to provide, to confirm the identity and get the user's sort of identity in the system, you typically will have other attributes tied to that user profile. So that's one kind of thing that you would use this for. Yeah. Is that right, Steve? Yeah.
Yep. That's absolutely correct. And if you're unfamiliar with ORMs and especially Django's documentation is really, really good. So if you need more clarification on, how to work within ORM, specifically Django, I'd check out their documentation. It's very helpful.
Okay, so I'm going to pause there before we all hit run. I don't know how many people are following along. I saw at least 5 or 6, 7 maybe that claimed service. So hopefully you're all there with me. And so the last thing is just to copy paste this command. So what this is doing is, so this is running the Django. It's really the development server, I guess. It's not really, this is, as I said, this is not a production setting, so please don't do it this way at home. And that's why we're running it on a non-standard port. Otherwise it would run on 443. I had created previously some let's encrypt certificates that are stashed here on these instances. So that's pretty much it. So we run it and there should be no fireworks. So it'll just sit there, and now the server is running and it's serving requests. So now we should be able to go to our very own instance, which in my case is, and this is HTTPS, and this will be dev, sorry, not dev, tut1.globusdemo.org:8443. And voila, we see something that looks like a shadow of the all singing, all dancing AC/DC portal, because that was its parent, its grandparent, perhaps, that it evolved out of. So this is the first of those 3 URL classes of URLs that I mentioned briefly on the one slide. This is the initial landing page that has 1 or more search indexes that you can go into. I always think of it as more like projects or communities or however you want to structure it. Of course, you don't have to have multiple, but again, I think that a lot of people end up dealing with, very diverse types of data across projects. And so you can serve them all through the same infrastructure. And this is sort of your dashboard for switching between them. So the one default sort of index that we've created and we have available for you so that you can actually use this right away, as we're doing here, is the TerraFusion data. So this is a data set that's, it's hosted and it's replicated in many places. This particular one that we are accessing is, as you can see here, on the Open Storage Network. The OSN, so it's on one of the OSN nodes. And when I click on it, you will see, again, something that looks fairly familiar, that, very much like that faceted search in that materials repository. So there you have it. That's really all there is to it. You have a working portal with full secure auth and a nice faceted index, and it does work, just in case you want to sort of trust but validate. If I do that, it will narrow my results down, and I can go and get even more narrow results, I assume. Filter results. Guess it's about as narrow as it goes on that set of dimensions. So these are the 23 HDF5 files that have whatever it is that I'm looking for, observational data from TerraFusion satellites. Okay, let me press long pause there because we're going to take a break. I think, yep, we're right on the mark here. Any questions, observations, things you want to dig into? Obviously, we'll have time, lots of time after the break as well. I don't intend to take all 90 minutes. Is there perhaps a Docker image close to the VMs we are using? Is there perhaps such a thing? Steve.
There is one coming. This repo, the cookie cutter, does include some Docker imaging and Docker Compose stuff. There's no documentation on it right now. You can theoretically use it if you are familiar with Docker and Docker Compose. The idea in the future, I don't know if it's going to be the near future or not, is to have more documentation and build out those Docker images a little bit more, as well as have some basic resources and examples for deploying those containers, probably to AWS. So that's the loose plan for Docker and containers and stuff in the future for this project.
Yeah, it's very much a requirement in the sense that we have some other communities that are using this framework extensively, and they do require it to be containerized. So it will be there, not immediately, but in not too distant future.
I don't want to stop the energy, of course.
Yeah.
Only saying we are going into the lunch break, the half hour.
Okay.
So I have to drop off from the tutorial for the moment. Please leave the Zoom session just running, and we will cut together the recording later. Your host, and I will drop off. And thank you very much.
Okay, thanks. I see that Annette is having issues, syntax errors. Actually, if you want to, I wonder if we can jump into a breakout room. Annette, if you want to stick around, we can take a look at that. Maybe let you share your screen.
Annette, I imagine it's probably exactly what you said there, the multi-word slug. I believe, and I might have to document this a little bit better, when you're choosing those variables, those slugs as you go through the cookie cutter process, underscores or dashes, if you want to separate multi-words out, should be used. Right. I noticed there's several places where that gets set. So do I need to just kind of start over to get it to do it right? Or is there a quick way to just change all of them? The quickest way in that sense would either just to do a search and replace, or just start over and rebuild the cookie cutter. Okay. All right, thanks.
Mm-hmm. Just to recap then, what we've done so far, excuse me, is installed sort of the plain vanilla portal with some standard pre-configured index that points to this TerraFusion data set. It's actually a pretty substantial data set, as you might have noticed from the number of objects. Each of these is sort of multi-hundred or tens of gigabytes sort of size HDF files, so pretty big. So this is what it looks like, and I should have also clicked, I'll do that now. You know, if you click on one of these results, you'll see additional metadata, of which there's quite a bit more than is actually shown in the faceted search. So this is another aspect of the portal where you get to configure what's exposed in the search index, what's available in the detail page, and all of that is also controlled via access permissions, which we'll talk about when we discuss search. And so when I'm on this page, sorry, I don't want it that big. You'll see some buttons here, so I can choose to transfer this data set using Globus transfer, so the asynchronous. So if I click on here, actually, I'll show you this one first, which is I can just download via HTTP if I wanted to. So if this was like a small file or something, I could, gosh, I don't know what's happening there. I could I would have to reauthenticate so that this endpoint, this collection, I can prove that I have access to that. So that would give me a download link, just like you would sort of normal browser behavior, file save as. But more likely what you would be doing is you have larger data sets, you would select those here, click the transfer and sync button, which then drops you over into the Globus web app. So it'll put you in that directory where those files are, and then you can select the ones you want and select, the target endpoint, and and then fire off a transfer. So just click and transfer, and off we go. So that's the standard flow, pretty basic, and yet quite powerful, I think. The other thing I can do is, if I wanted to use this file elsewhere, I could also click here to get a link. So this is, as you can see, just a regular URL, which I can copy and paste somewhere. And if I were to go to another browser and try and access that, let me actually show you what that looks like so you can see the security model at work. If I were to go here, this is my Safari now. Click on that. You'll see again, I'm not authenticated here. This sits behind the Globus Auth, so I would have to authenticate. And I was logged in here previously with that ID, so it just confirms. I grant consent to use that to have Globus access that collection on my behalf, and then I can download the data. So pretty nifty. All right, so let me switch briefly back to slides then. Where were we? Right, so we talked about registration. We all did that, or at least those that are following along. We've done that. You've now become experts at SSHing. Yes, I do want to stress this top point here about, or the sub bullet on the top point, which is that the way we've deployed this portal is adequate for sort of experimenting, just finding your way around things, and starting to build things, but it's certainly nowhere near appropriate for production use. There's at some point we're definitely going to add to our documentation some sort of pointers to best practices and perhaps a recommended layout and tooling, but you certainly should be using more proper WSGI or ASCII servers instead of the built-in, that one server that we did, that's sort of Django's built-in development server, which is not really suited to production use. And we talked about containers that are coming in the future, so that's definitely there. Okay, so we're going to dig into the search side of things in a bit more detail, because obviously having this index with your portal doesn't help you very much, other than it's a pretty cool data set. So we're going to talk first about the search service, what it is, how you use it, and then we're going to talk about it in the context of the portal. And specifically, we're going to make some modifications to the portal to use a different search index that's just for the purposes of the tutorial here. So search, and I said this briefly, I think, in the earlier session, one of the key aspects of search is that it's a metadata store, but with these fine-grained visibility controls. So what that means is you can specify even down to the individual field level what is visible to whom. So you can say that these 2-3 pieces of metadata are only visible to the owners or the people who created these things, whoever they may be. So there might be a group that the owners belong to. So they're the only ones that can see those. It doesn't show up on detail pages for anybody else. It doesn't show up in search. Or you could you can set certainly different permissions on the index data, the metadata, than the data. So I have a use case that I'll show you that illustrates that as well in just a little bit. The other really cool thing and very important thing is that we decided a very long time ago we weren't going to get into the metadata wars and try and get everybody to be on the same page and agree to schemas and things like that, because if you've been down that path, that's not really practical. So the approach we've taken is that we'll support whatever metadata schema or structure you wish to use in your application, whatever makes sense for your project, community, discipline. If you have a standard ontology that's used in your research, that's great. You can sort of mirror that or replicate it in the structure of the metadata you provide to Globus Search, and the service will just ingest that and continue building it. And because it's really up to you how you define what's a search field, what's a facet that shows up in search forms, and so on. So once you have data ingested, once you have data in the index, there's two ways you can search. There's a simple search, which is just like you pass the URL to the search index along with the query string. So that's very simple. Maybe you just want to search on some text throughout the index, just full text search. The other one that's actually the more powerful one, which is more likely what you would use if you had complex data sets and you wanted to present them in some sort of nice user interface, is to do complex searches with using an actual post call. So the first one is just a regular get with a URL. This is an actual post where you give it a document in the body of the request that actually defines the various filter conditions and values for things. And however, you can get sort of arbitrarily complex queries to return just the subset of the data that you want out of the index. And that, obviously all fully documented at that URL. So again, I want to stress this point about distinct policies, access controls, but applied to data and metadata. For data, again, it bears repeating that you should be always thinking about using guest collections on Globus. Again, guest collections are storage repositories, if you will, that don't require explicit local user accounts for access. You can manage the access strictly through the application using Globus Auth as the broker of the access control lists. And then metadata, you can set permissions on the individual elements. So this is what the ingest looks like. We don't have to look at the code, but it's basically there's a standard type. Oops, shouldn't be clicking on that. There's a standard type for all ingests. So that's the G meta list, which is a list of entries for and subjects. So here's the subject. This is the actual data file or data set. And here's an example of the visibility. So in this case, we're saying that this index entry is visible only to this specific identity. So this is really a very, very private index. It's only visible to one user. You could also specify and restrict identity to a group, a Globus group, or to your application. So your application may have access to the metadata, but may not expose it to the user. The user may only see subsets of the metadata or just the data or some other combination of things. So again, this is another case where the application can act just like a user would as far as determining what's accessible and what isn't. And then this is an example of a simple search. So here's the query string. Here we're looking for all files of type HDF5, and we'd get back some result. And then if we're doing a more complex one, here's one where you actually specify in the body of the request, as I said, the various parameters that you want to, the various fields that you want to filter on, and the values and ranges and so on. And so I just wanted to illustrate this with an example. I'm not going to show you this portal because it's something that was in a separate project and actually has a lot of private health information, personal health information. But there's a project called the CR3 Cancer Registry Records for Research, which is essentially a federation of cancer data repositories. So University of Pittsburgh, the medical school in conjunction with UChicago and some others got funding for this and started building this structure where various groups can curate their own collections of cancer data. A lot of this is also just, clinical data with patient information and so on, as well as perhaps some de-identified items in there as well. And then indexes are created for these data sets. The data actually live at the respective institutions, but the portal holds the sort of federated index and can say, oh, you want, records for, hepatic cancer, whatever, and we have some data here, some data here, some data there. So it can look across this federated set of repositories and give you results. And you can see that, and this is a great example of where that sort of bifurcated access control model is used, where the search index only contains de-identified data. So any metadata that contains PHI is not indexed. And you can't see record level data in the index. You only see aggregate. So you see things like this, beam radiation, you see total collection counts and things like that. And it's only once you get access to the data that you can obviously get the individual data files themselves. And I won't go into the architecture, but it's just it's a very high level view. The one key thing I want to call out is that this is an example where there is actually a flow, a human in the loop in the authorization flow, where if you request certain types of data, it may require that a human looks at that, again, because this is dealing with clinical private health information. But this is a snapshot from, this is actually not real data. Again, it's protected stuff. So this is what that portal looks like. So again, you log in with Globus Auth. In this case, there's some limitations as to what identity providers are accepted. So that's another thing that I didn't highlight before that you should be aware of. So in your portal, even though you could use any of the 1,500 odd identity providers that Globus federates as part of Globus Auth, you can actually restrict that and say, no, this is an internal use only portal. So you must, users must present an identity from my institution. So, or from my institution and this other institution that we're collaborating with, but nobody else. So that way you can, even though someone might be able to get to it, they won't be able to authenticate. And that's all, again, enforced by Globus Auth. So here you see, again, there's in this case, there's sort of a Google-like free, full text search. And then you get the progressive sort of narrowing and widening of results through facets. And then there's this cool charts that show you, again, because they're not showing individual items here, unlike the example that we've been working with. This just shows aggregate data at the index level. And then once you pull the data down, you get the detailed records. Okay, so that's just a high-level flyover on the search service. Let me pause there and see if there are any questions. Otherwise, I'm just going to quickly show you what that looks like, and we'll do an exercise to show you how you extract and ingest metadata. Okay, nothing in the chat. All right. So let me, let's see how we're doing on time. I think we're okay. So we have a Jupyter Hub setup. For those not familiar, this is a way to host Jupyter notebooks, which are interactive web pages, basically little apps for running code and especially for educational purposes. They're very, very powerful. So we use these extensively and we make them available. So you can actually go to this URL here. Sorry, I took the slide off the page. Jupyter.demo.globus.org. So if you go there, you will see the Jupyter Hub, and you can click login or start my server, and it'll spin up a VM and a notebook server instance for you, and load our standard notebook. So we have an open repository, a GitHub repo that has all of these notebooks. You can actually take them and install them on your own machine and run them locally if you want to as well. That works just as well. But mostly I wanted to poke at a couple of things here to show you how the various services work together. So the first thing I'm going to show you is, so I'm going to go into this notebook, and you can run, if you haven't used Jupyter before, you can run these various cells. So it's actually live code that you can execute here on the fly just by hitting Shift Enter, and you'll see the little star asterisk flash in there when it's executed, and it'll mark it as run. But I want to point out a couple of things. The one is how the authentication works. I've talked a lot about tokens and Globus Auth giving the application tokens, etc. This is what it looks like if you care. Again, most of this is handled for you in the portal framework, so it's sort of opaque in that sense. But if you want to dig into it, of course you can, and you can change this. So here's an example of where this application, this being this Jupyter Hub, is actually another client application that's registered with Globus Auth. So when our Jupyter Hub runs, users authenticate through Globus Auth, and their credentials actually get stored in the Jupyter Hub database. I should say not their passwords and stuff, their actual Globus tokens. And so we can retrieve those in the Jupyter Hub. So we actually pull them out of the database environment. We put them in the environment when the notebook loads, and then we can pull them out using this mechanism. And so here you can see we're in this notebook, we use 3 different services. We use the transfer service, the search service, and a mint service to actually mint a persistent identifier that's going to go into our index. So, so we get 3 different tokens because, again, this is access to these services is based on scopes. So these are all different sort of namespaces with different scopes. And so we get different access to all of them. And then from there, we can go ahead and use those tokens. So that's the one thing I wanted to point out is how that authentication looks like behind the scene. Again, once you have those tokens, you don't really do anything with them other than create a client, sort of a handle, if you will, to talk to that service using that token. And after that, everything is kind of handled without you having to do anything with respect to authorization and so on. The other thing I wanted to show you is, just an example of, metadata that can be ingested. So here's just a little tutorial, sort of a sample, trial index that we create. And we're just putting in whatever metadata we want. This is pretty standard stuff if you're doing publication or contributors, keywords, etc. But again, this could be arbitrarily complex based on your needs. You define the metadata. In this case, like I said, we actually mint an identifier. And then here is where we actually put it into Globus search, this line here. Oops, this line here. So we just do search.ingest. We give it the index ID. Again, so each index in Globus search has a UUID, just like every other resource in the Globus platform has a UUID. And then we tell it what data we're indexing. So this is an entry for this subject here. So there's the subject and then its associated metadata. And here you can see this one is visible to everyone. So this index is actually generally publicly available, and so all the data in it are public because this is just tutorial, temp stuff. So that's just as a sort of a pointer to something that you can use if you want to dig around search. And it's actually pretty cool because you can experiment with your search queries in a notebook environment before you actually deploy them in a real app. All right, so that was at a high level. So let's actually go and talk about one of the harder things, which is extracting and ingesting data at scale. So typically, when you get a data set, it would be nice if everything just came with the data all nicely carved out in some structured format. That's not always or very often the case. So we have to do some work to extract it. So one of the things you may end up having to do as you build out your Science Gateway or your whatever web application is write some custom extractor to look at some data and pull out metadata, and then structure it, put it into a form that you want to use in your index, and then send that off to Globus search. So ingest into your index and use it. So I'm going to go back to the instance, and you can follow along with this one or not. You can just watch me do it. This is actually another repo in our GitHub repositories. So you just go to github.com/Globus. Should have showed this earlier, but we've already pulled from this repo, obviously, because we installed. So here's the cookie cutter app that we just installed. And the Django portal framework is somewhere down here as well. But the one that I want to highlight is this one right here, searchable files demo. So I have this repo cloned on the instance, and this is a really great repository. It's a great example because it's a sort of a turnkey, sort of end-to-end set of tools for doing very simple metadata extraction. In this case, what it does is it extracts file system metadata. So it will look at, you point it at a directory and it pulls out file index metadata. That's not really very exciting, but it serves as an example for you building your own extractor tools. And so all the machinery is there, and it's very nicely done with, with error handling and so on. So once we install this, which it's already installed on our instances, so we'll just run through it just to see what the output looks like. But there's 4 pieces to it. So the first is extract the data and then put it into some structure that will be able to be assembled into this JSON file. So then pull all the data from the extraction process into, sort of assemble it into these larger files to produce these bigger documents that can be ingested. Because one of the things you don't want to do, for instance, if you're indexing some massive data set, you don't want to call the ingest, you don't want to submit an ingest request for every single of potentially millions of records. What you want to do is pull them all together and then send that as a larger document with multiple entries all at once. So that's what the assembler does here. It gets it into a structure that can be ingested sort of in bulk. And then the submitter tool actually sends it to Globus Search. It does the sort of the post to search index. And then if it's a really large task, obviously you can imagine it could take a long time. In fact, I ran an index, the other day I was indexing some other public data set with about 2.5 million records. So it took a while. It took some number of few tens of minutes, I think. So you can actually have a watcher process that will sort of track it and make sure it's still running and so on, and let you know when it's complete. So simple stuff, but something you probably will end up doing if you're creating a new index to use with a portal. So it's already installed. So what we're going to do is just go right here to the setup. So if you want to follow along, I'm going to put this off to the side so we can see it. Actually, let me make this a little smaller. Where are we? So in your home folder, there's the searchable files demo folder. So we'll go in there, and everything just needs to be running there. So the first thing we do is log in. So this tool is actually just another client to Globus Auth. It's been registered with Globus Auth. In this case, this is what's called a native app. It can't keep a secret because it's a bunch of scripts, so we wouldn't have any way to sort of securely put a secret because we want to distribute this thing all over the place, obviously. So you actually have to log in, go through what's called the native app flow, which is the sort of the 3 legs are sort of a human in the loop. So the first one is I take this link that is provided. It's a one-time sign-in link, and I go off to my browser and I paste it in there, and it takes me through the same consent flow as I did before. And it says, this demo wants to view your identity and it wants access to search because that's what we're going to use. So those are the scopes that's requested. So I get back this code, and then I put the code in here, And now this application calls back and exchanges that code for those access tokens that I showed you earlier. So different flow in terms of the mechanics, but the underlying principle is the same. And the end result is the same, which is this application now has these tokens that it can use to call the search service. So I'm logged in, and you can see here it writes my credentials to some local database. And this is fairly common for these types of scripts. You can actually write it to a database, and actually if you get a refresh token along with your access token, then you don't have to log in again, because every time you request access tokens, that refresh token is also refreshed. So it's again this evergreen process that I mentioned earlier on in the session. So now we want to create an index. If it's the first time you're using the Globus service, or if you just want to run through this fresh, you can create an index, or you can tell it to show you an index if you have. I don't think I have one that's suitable for this, so it's probably going to say no, you don't have one. So let's run create index command. By the way, I can this is just a normal set of command line tools. I can type help, and it tells me all the things I can do. So I'm going to create this index. Oh, and I knew that was going to happen actually. So this is, it's telling me that I've reached the limit that's allowed for these trial indexes. And so the search service imposes some limits on usage, so that people like me don't do things like I was doing the whole of last night, which was creating and deleting indexes and creating more and more indexes to test things. And because someone could inadvertently or even maliciously potentially start hitting the service with thousands or millions of requests and basically create a denial of service. So we limit the number of indexes that free trial indexes that can be associated with an account. In my case, I think I have all 5 that I'm allowed. But if you run this, you should be able to run through it all the way. I want to see if I can actually create, see if I can log in as a different person and just run it as a separate account. Give me 1 second. I'm going to log out. It's really not satisfying to not complete the demo, even though I kind of had a nagging suspicion that would kick in at some point. So I want to go log in on a different browser where I'm not logged in. So I am going to log in. I'm going to log in as a different user. Okay, so I have a new code that I'm going to paste here. So I'm logged in as a different user now, so now I should be able to run the create index command. And there's my new index. And that's the index UUID that you use basically anytime you call the search service, you're operating on an index. So that's how you identify it. So now we can run through each of these, and I'll show you what it's more interesting to sort of see what the outputs of these are. You can run help to see what it does. But basically, this is the first one is the one that extracts the data from, you can give it a directory path, and it will go and basically parse that whole path and pull out all the metadata. By default, there's some files here included in the demo in the data directory. So that's what it looks at by default. And it puts the extracted results in output. So let's actually go to output and look at this extracted file. Oops, I need to go in there. So you'll see this has created a record, a little JSON file for every single, I guess, file that was in that whole directory structure. So I can look at one of these and you'll see a familiar structure that you saw very briefly in that notebook. Oops. So that's what it found. Oh, it found this file and extracted this metadata. So it's a file, it's an executable file, etc., etc. This is what's going to be ingested into the index. But before we do that, we want to assemble all of these into a document, because again, there could be many of these, and you don't want to have individual calls out to the index. I'll go back to the root, and then I'll run the assemble command that brings it all together. And again, I can look at that. So it's created three different documents. I'm not sure why it did that, but I think you can set what sort of the breakpoints are for these docs. So this has actually extracted some content, but there's the metadata record. Okay. And so I'm going to now submit this. This is the actual ingest step. So I'm going to tell Globus search, here is some data for you. So the submit runs that. So this is going to take a little bit, and it's done. Again, if this was a long running process, there's a list of IDs that gets stored. So these are the different, the three individual ingest tasks for each of those three individual and input files, metadata files. So that's going to get ingested, and if I wanted to sort of track that process, I could run the watch command, but I'm sure it's probably done by now. Yeah, so all three tasks completed. So yeah, that's pretty much it. So a lot of black magic there, or not black magic necessarily, but it's not a dark art. It's sort of shielding you from a lot of the details. But if you're going to do this yourselves, we've given you enough examples to go and sort of build on and extend and apply in your environment. Okay, so let's see what we have next. Any questions on search? So I'm going to go back to the portal and show you how we would use your own search index in the portal. Okay. Okay, so let's see, what are we going to do here? Trying to figure out the best way to talk about this, so I don't want to run out of time. What time is it? Oh, okay. So we have a number of tools, a number of approaches that we use in Globus to automate things. So to do things at scale, we have in some cases very targeted tools like the timer service. So if you want to run repeated scheduled transfers between some systems, you can create that and put it on a schedule. It's like a cron job basically, except it submits periodic task transfer requests to Globus. Data gets moved, gets notified, you get reporting. It's the same as if someone's sitting there clicking the button repeatedly. It's done for you. That's very targeted. The command line interface, which I haven't showed you, and we really don't have time for that, but if you want to do sort of more rudimentary still, but a little bit more in the way of automation and have these simpler tasks, multi-step tasks, you could actually script them out. We have the command line is fully fledged tool, has access to all of the almost all of the services, and in some cases exposes even more options via the command line than you might see in the web app. So you can do a lot with the command line. You can build it into your existing scripts. Very common use is to stage in data for compute somewhere. But the one that's most interesting is the Globus Flow service. So I'll get back to that. But in the meantime, what I want to do is actually talk about how we would, if we use one of these services to generate a massive index and all the data behind it, how would we actually enable that in the portal? So let's go back to that. So I'm going to open up, I'm going to go back to that repo. Sorry, was there a question? No? Okay. I heard something. So I'm going to go back to that repo where we were copy pasting the commands to install the portal and go back to the root directory. So we're going to do the second half of the stuff in the README. So there are 4 places where we're going to make some edits to the code. The one is in this search.py file. So if you recall, this is where the settings for the index are stored. So because we're obviously going to point it at a different index, we're going to change that file. And I suggest that when you do this for the first time, it's kind of handy. Just make a backup copy of these files. Then you can always just revert and can compare and contrast when your stuff doesn't work straight out the gate, which certainly never does for me. But you might have better mileage on that one. So we're going to define the index details in that file. In this fields.py file, we're gonna identify where the data fields are going to come from and what they're going to be named, so that then the application, the portal, the gateway can refer to them in the UI and throughout the app. And then the next 2 are just basically changing the templates that are rendered on the screen to tell them that different data is being provided so that they can show the appropriate results. Because it's a different index, it's going to have different fields, different search facets, and different subject names and so on. So let's look at each of these in turn. First thing I'm going to do is open up this search.py file. I'm not going to make a copy here. I'm just going to overwrite it, and we hope won't make too many typos. Okay, so this is, oops. So this is what's currently in that search index file, and hopefully you'll recognize some of this because we just saw it on the web app. In fact, let me, in parallel here. So I'm going to go and run the web app in a TMUX session. Let me just deactivate here. So I'm just going to go here and run it. Oops. Give me 1 sec. This way I can just switch. Oops, sorry, not that one. Just want to run this. Whoa. What did I do wrong there? Oh, I'm in the wrong place, of course. Okay, so that's running. All right, so this is what we're looking at here. This search index, it's the TerraFusion index. Wrong window, okay. So TerraFusion index right there. That's the index UUID. That's really what matters from Globus search perspective. But this name is actually something that gets used to create the landing page. This homepage here, and to create some of the URLs for each of these indexes. So you have to specify that. And here you can see some of the fields that are returned from the index. So there's some specific fields like the date and the title. So you can see these are listed here, the date, this is the title, the name of the thing. And then there's some additional metadata. And then here is, most interestingly, where the facets are defined. So the things we see down the left here for searching the index are all defined here. There's location, dates, orbit groups, just like it is here. And for each of these, you can see there's different types. And we have other ones that are not shown here, like sliders for numerical range values, things like that. So here we have one orbit is these orbits are, I guess, many different numeric values. So we break them up into ranges, based in chunks. Other things tend to be more discrete values like years and so on, or location, etc. So you define the facets you want, and based on the type of data that of the values for that attribute, you can decide on an appropriate facet structure. So that's really all there is to it here. So what we're going to do is we're going to replace this with our own. And this is where I have to rely on having tested this thoroughly, which of course I did not. So I'm going to grab the search.py file here. And all we're going to do is replace, we're not going to replace this little function at the top here. We're just going to replace the search index. And I left the TerraFusion name because otherwise we have to change it in a few other places. So all I did here is I changed the UUID of the index, which is really the thing that will change the data that's coming in. And then, of course, I changed the metadata. So this is a very simple index that has, again, a title, and then a URL to get the actual data item, and then some additional metadata. And I've pulled out 2 of those bits of metadata as facets. So the year that this data was created, and then something called the survey number, which was, I guess, whenever that, that experiment or survey was run. So I'm going to just take that, copy it, and just override this whole JSON block. Okay, so we'll save that. So I'm going to wait. I don't know if others are following along, but I'll just give you a little bit of time to do that. So we're editing. I'll just jump back here. We are editing this file here. It's off your home directory, wherever you put your project in settings/search.py. And we're replacing that search index with this file, the search.py in our repo. Okay, so that's the one. So that's the Globus, that's sort of talking to the Globus index. Now we're going to talk about the fields that are going to be pulled in and used within the app. So we're going to edit the field definitions in this file here. So that's a level up. So that's right there. This is the file we're going to, oops, not that one, sorry. I think, inside there. So the top level of that that particular in the app. So that's what we're indexing. So rmate that. Oh goodness. So this is what the current fields.py file looks like. You can see that this is where some of the transformations are done to the data that comes back from Globus search. So you see for every result that comes back, in this case, there's a files element in the JSON, and inside that there's a file name. So that's what gets rendered as the title. That's what gets passed back as the title, the date, and so on and so forth. And then all the other metadata that shows up is done here. And this is just kind of a little an iteration that an iterable that runs through here to get this data here. Let me go back to the portal. So when you click on the detail, oops, I've already changed the search index, so I'm going to get no data. Should have saved you a picture of that. But if you recall, there was a lot of additional metadata when we drilled down into the detail page, and this is where that data is sort of transformed and prepared. So this file, we're just going to create a whole new one. I already have it created in the repo. So there's fields.py. And I'm just going to take the whole thing. Oops. I don't need the GitHub footer, that's for sure. Not used to not having all the controls here. Okay. So this is a little more kludgy. I've sort of hard. I could have iterated through it if I'd structured my index a little better, but this is just a little more sort of pedantic and obvious. So these are the different fields that are coming back from the index, the various bits of metadata. And we also have a title, it gets stored the same way, and there's a corresponding URL. So that URL, by the way, is that link that gets displayed on the details page as an example. And then this link here, the Globus app link, is the one that I click to go see this inside of the Globus app to transfer the data. So all of this stuff is dynamically generated. You can see these correspond to all of these here. So there's files, the title, that, and then the general metadata is what gets created in this list here. So I'm just going to save that as it is. And now if I try and load my portal, it's probably going to be very broken because it doesn't know anything about any of this stuff. So I'm surprised it's even giving me results here. I wonder. Shouldn't even be seeing. Oh, it is. Sorry. Never mind. So yeah. So actually you can see that some parts of the old template are still rendering. I didn't pay attention there, but you can see we have different facets now. We have the two facets that we defined here, year and survey number. So here they are, and there's the search results. So this is a pretty small data set, a couple hundred items, and yeah. So it's displaying the title. And then again, I can do the same thing here and filter it, or I can just say, give me all of that, however many results that is, 44, and off we go. Voila. So we're talking to a new index. It's not looking very pretty. I could leave the exercise to you, the attendee or the reader, but it's just a couple copy paste. I'll do that. So I've got modified templates, so this can actually look a little more useful. So the one template is inside, it's sort of buried a few levels in. So this is the, actually, let me do the other one first. Inside of components. This is the search results template. So this page here needs to show obviously different things because we no longer have these metadata items. This is from the old data set, the TerraFusion one. So so this file is going to override that. So if you've seen any kind of templating language, this will look somewhat familiar. They're all mostly the same. Both this and Flask, I think, use Ginger style templating language. So here what we're going to do is we're going to show three of the metadata attributes: the latitude, the longitude, and the altitude that these images were taken from. This is actually an excerpt from the low altitude disaster area imagery data set. It's something that FEMA uses. They get people to fly at sort of pretty low altitude, in some cases like 50 or 100 feet, and take pictures of unfortunately disastrous areas. So let's edit this file here. It's in Project Slug. By the way, all of this stuff is documented and will be increasingly better documented because we're just in early releases of this. Oh, that didn't work too well, did it? Let me just see why that didn't work. Oh, maybe I don't have. Huh. Okay. I must have a typo there somewhere. I don't know. Templates. Bizarre. Oh, hang on. That is weird.
You've already CD'd down into the second SG BAS, and that's not where templates is.
Oh,
Go up one.
you're right. Sorry, my bad. Put the wrong file there. Ah, okay. Thank you. Couldn't be perfect, could it? So this is, so we'll go in here, components, and it's search results. All right. Okay, so we edit that, and we're just going to replace it. So here you can see where those where all those fields are coming from. So these are the 4 that get listed here. Obviously, there's no data to go with those here because this is a totally different index. So we'll just blow all that away and replace it with our own cool stuff. Oh, that's not formatting it. Oh, that's the wrong. That doesn't look like template code. Hang on. Okay. No. That's the file I want. Okay. So that's our new template. We're going to show just these 3 attributes, and everything else pretty much. If you look at the 2 templates side by side, they're largely identical in sort of the headers and the structure. All I've done is change these fields in this case. Everything else just kind of flows through. So there's extensive reuse. You really don't have to reinvent much at all. So now with that template in place, if I go and reload this page, I should start seeing data. Okay, so there's my 3 metadata attributes that I chose to display on the summary page. And then the last thing is to make the detail page look decent. And that one is in, where is it? It's in templates, this one here. So this overrides, I hope, that file. Let's see if I've got this link correct. No, I guess not. Okay. I think I've got too many slugs in there. Okay, so basically this file is in here, I believe. Nope. Maybe it's in V2. There it is. Okay, so that's the detail overview template right there. So I'm just gonna do that one. And you can see this is actually it's a composable page. So there's it's broken out into little chunks, little blocks that get inserted and dynamically populated and rendered at runtime. So there's this DC metadata that has some of it, then there's the detailed general metadata. So if you have lots of metadata and you want to structure it and you want to render different parts differently, you can have these nice little sub-templates, break it out. In my case, I'm going to go from this to something even simpler, because all we have in our case is just a handful of things. So this is literally the entire template. So copy that and save it there. And now we're done. That's it. So now we've changed the index, updated the field and search structure definitions, and now we can poke around. So I can clear the filters, and when I click on one of these data sets, I will see its metadata, and I will see the corresponding links. So if I want to go and get this, this will now send me to a different endpoint, because this data set actually lives somewhere else. You can see it lives on this tutorials endpoint on ALCF Eagle. So yeah, that's it. Everything else works the same. I can download via HTTPS. So these are images. So if I want to take a look and say, is this really the one that I want? I think I'm looking for, you know, whatever damage from Hurricane Hugo. Again, I'm authenticating because this is a different request to the HTTP. So I can save it to downloads. And if I go to my downloads folder, well, actually I can just open it here. I can just see, right? So that's what was downloaded. So this is clearly not a happy place. It looks like a little twister came through there somewhere. So that's, again, pretty brisk walkthrough, but sort of try to expose you to the core things you're probably going to want to change to make this usable for you, which is changing the index. Of course, that's a starting point. The next piece I'm going to talk briefly about is how you might add some compute aspects to this, but I'm going to pause there for a bit and see if you have questions on this or anything we've talked about thus far, because this is really the core of what we wanted to share with folks today. Anything at all? Okay. Can also ask about my March Madness pool, which was not very good. Okay. Right. So if you followed along, great. If you didn't and you still would like to, like I said, I'm going to have these instances up for a couple of days here, probably tear them down like on Thursday night or thereabouts. We don't want to burn too much credit, but yeah, they'll be there for you. So I will go back to slides just briefly and talk about some aspects of compute. So for the most part, well, certainly everything we've talked about up till now has to do with data. And Globus has, since its inception over 2 decades ago, well, originally it was actually about compute as much as it was about data. In fact, probably more about compute originally. But then when it became this cloud-hosted service, it was strictly about the data. And now we're sort of going back to our roots in some ways and starting to add aspects of compute to the mix, because no meaningful flow is really just about data. It's compute and data and other things too. And so one of the ways that we are enabling or bringing compute into the fold is using this service called flows. So you can think of flows as a way to reliably execute arbitrary data and compute processes at scale. So this is something, and with potentially or optionally with a human in the loop. So many, people ask, well, how's this different than, like a workflow engine or like Galaxy if I'm running my my Galaxy little flows. So it's different in the sense that this has the reliability aspect. So the same way that we have file transfer, reliable file transfer, where you sort of outsource the execution of that to Globus, you don't have to worry about, data integrity, et cetera, and limits on APIs. Globus will sort of handle all that for you. The same way here, we will take care of managing this end-to-end process, and we'll also allow humans to inject themselves into it, because in a lot of cases, like in that one example of the cancer data, yes, you might have a flow that sort of handles the permission setting and access to the data, but a human has to somewhere go and click a button or fill out a form or an approval or whatever. So you can do all of that. And so the way these flows are structured, is as a series of so-called actions, pretty straightforward. And actions are affected or enabled by action providers. So the action provider is, if you will, the API or the bit of code that allows the flow service to take an action on some resource somewhere. And so for all the Globus services, or most of them right now, I think we have action providers. So if you want to run a transfer or ingest something into an index like we just did, there's an action provider for that. And you just, in your flow, you define a step that says ingest into the index. You tell it which action provider to use. And when it gets to that step in the process, it will take whatever input data it requires and do its thing. And then these flows, right now, they are triggered. You can trigger them by programmatically, or even through the web app, which I'll show you in a second. But we're also, we have a trigger service that's out there. It's not fully in production and available generally yet, but it will be, so that you can have them triggered by events, which is really critical in that first use case that I talked about with the instruments, where you want to, the minute something or some files come off the instrument or the end of the experiment or whatever, you have all the data, you want to trigger one of those flows to analyze and etc. So that's exactly, in fact, how it's being run on some of the beam lines at the advanced photon source. That's, if you care, this is actually, we didn't build big time scalable, robust magic ourselves, because that requires a lot more than our small team. So we actually use a service from Amazon called Step Functions that we've built around that. So the core of the service is Amazon Step Functions, and then we've made it such that you can invoke the step functions with the same fine-grained access controls that you get through Globus Auth, and with these action providers that allow you to talk to these different services. So here's a list of this action providers. I don't know if this is the current one. There's probably a few more that we've built out since then. But the one thing I want to point out here is that if you have a task that you want to execute somewhere and there isn't an action provider for that, we have an API, a toolkit that allows you to build your own action provider. It does require that you write essentially a service with an API that can be called from flows, but in many cases, these are very narrowly scoped things, because it's not like you're writing a full API. Like if you have some, complex analytical package, maybe there's just like a job submit API, and might even be there already, and you just write a little shim for it that Globus flows can use. So there's a little bit of code required here, and then you have to obviously have that service or that API available when you're running the flows. Let's skip that slide, and then just show you what these flows look like. So I'll show you from two perspectives. So the one perspective is the easy perspective, which is the end user. So you can think of the flows life cycle as having roughly 3 or 4 phases, I guess. The first is you develop the flow. So you actually have to define it, the various steps and the parameters, and the way it actually looks when you write it is just like one big JSON structure. The next is you have to deploy that flow. So you have to tell the Globus Flow service, hey, here's another flow with the appropriate scopes for the things it can access, and in terms of who can run it and who can update it and so on. So again, Globus Auth comes into play here, both on the management of the flow as well as at runtime. And then the third step is to make it available for people to run, so anyone can come, not anyone, those that you designate as having access to it as sort of runners of the flow or executors of the flow can go along and run it. And one way they can run it is just to go to the web app here, click on flows. It's the first time I'm logged in as a different user here, I just recalled. And so this user has never run flows before, so this is what you would probably see. You can go to the library where there are some publicly or some flows that are available, and you can see the ones that have a start buttons or ones that I can actually run. So as a user, I could, someone has created this and deployed it for me. This is what we've actually done for the scientists that use some of these beamlines where the data ends up in that portal. And so you can, in this case, invoke it manually by clicking start. If you wanted to see what one of these looks like, this is now the sort of the not pretty side of it, because this is what a flow definition looks like. It's really not that complex, just a lot of stuff because it's a lot of structure. And we actually have tooling that will automatically generate all of this. So I'll point you to a repository at the end here. But the point is, all that complexity is something that you deal with once or maybe twice if you update the flow, but you define it, you deploy it, it's in there, and then users can run it. And again, it can also be triggered automatically by other, other apps, or in our case, by the portal, right? And that's really where we bring all this stuff together. So then once it's running, you can monitor it. If I were to start the flow, it'll prompt me for input, etc., and then I can monitor it, and etc. So, so that's the user perspective. I showed you a little bit of what's behind the scenes. Very useful flows are things like, again, to tie it back to the portal, taking some data from the portal, so finding it in your search results. So one way you could see, I could see sort of integrating this, and I was actually going to try and demonstrate this, but I, at some point, my knowledge of the way this is done kind of ran a little thin. So this, you could have a button here, let's say, that says, analyze or render or decompose, or whatever the case may be, whatever is appropriate for this type of data set or data item. And then clicking that button would pick up presumably some values from here, like the name of the file, the location, perhaps some of the metadata, and go off and run something somewhere, and then have some results show up somewhere. And that whole process of put the data somewhere, run something, get the products, put them somewhere else, and potentially even update this metadata, update this index, all of that can be automated by a flow. So very, very powerful stuff. It does require a little bit of development, but once it's in place, the big value here is that it can run scalably, it can run very reliably at scale. And one of the ways, and so I'll close here, so I want to leave some time for questions. We haven't had many questions. Hopefully people will have some. One of the ways that you can call out to execute things is through this service called FuncX. Now, this is something that is, from our perspective, very early in its evolution, even though we've been, it's been in development and it's actually being used extensively, again, in that advanced photon source and a few other places. But it's, as the tagline said, federated function as a service. So this is a service that allows you to run some function, some compute job, typically something very self-contained, on any resource out there that you have access to that is actually presenting itself as one of these FuncX endpoints. So this is analogous to a Globus endpoint today, a data endpoint, which is we'll just call it an endpoint collection today, where we're getting access to data, to a data resource. This FuncX endpoint is actually exposing a compute resource, and the service is hosted, and it works the same way, just like the flows does, for example, in Globus. So you define a function. So it could have a little Python function, and actually you can try it if you just go to this binder or notebook here, and you can run it right in the browser, get an idea. But you define a function, you deploy the function on the endpoint, or first you create the FuncX endpoint, the compute endpoint. But if it's already there, you just deploy one or more functions, and then you can invoke those functions either directly or, again, as part of a flow. So if we look at the documentation here, here's the action provider for Globus flows to actually to invoke a function. And it actually is a very simple action provider, at least from the perspective of us as consumers of this, because the only thing we need to do is pass it 3 inputs. We give it the name of the ID of the FuncX endpoint, the ID of the function that we want to run, and then the payload, which is basically the input of the data that's expected by that function. So that's all that goes into sort of the heart of the flow, the schema that gets designed for the flow. And then you can see here that this is the service, automate.funcx.org. That's where the hosted service is running, and then it will execute this function on whatever endpoint I specify. So the one thing that I actually was hoping to show, which I will maybe show you the next time, it may be not the mini gateways, but the maxi gateways, or the main conference, is that you actually take this index that we have. It's got all these pictures, and you saw me like download and open one to look at it. Well, a nice thing to do would be to have little thumbnails. So, hey, guess what? I could just write a flow and just have it run over all of these images, go generate a thumbnail. It's a very simple task. It's very atomic. I can launch it in parallel at scale on a whole bunch of these FuncX endpoints and just have it run. So if you're familiar with things like Amazon Lambdas or Google Functions, it's the same idea. It's running a function in the cloud, except in this case, it's not just in the cloud. It can be on any compute resource where you can deploy one of these execution endpoints. So in my case, I tested it like on my, on my own machine. I tested on EC2 instance. There's supercomputer endpoints. So it's all the way up and down the compute scale. Okay. All right. That was a lot of stuff at the end there. So I'm going to press long pause or stop there and open it up for any discussion, any questions. And I'm happy to show you more stuff. Just let me know. But hoping you have some questions. Right. Okay. I know Zoom 3-hour Zoom sessions are not ideal. But in any event, thank you for hanging in there. I hope I can't tell how many people were engaged, but I hope some were. I certainly noticed some people were doing things, so that's great.
Question come to the chat.
Sorry.
When I follow a transfer link from my portal, it says endpoint not found. Is that expected?
when you follow a transfer link from the portal. Did you do this? You did the modifications that I was doing here to the index?
Yeah, I did all of them.
Okay. If you paste the link in, I'm just curious. So it should endpoint not found. That's odd because it's all in the .6 Terrafusion.
Kind of makes me wonder if possibly the UUID got copied incorrectly or something.
Oh, it could be.
Maybe like a digit got missed or something.
So is it this link here? No.
Yeah.
Oh, it's that link. Well, let's just see if it works for me. Well, actually, I should check yours. I mean, that one seems to work.
What's your instance? Oh, I'm sorry. You got it right there.
TUT6, yeah.
You got
It
right.
shouldn't.
Oh, I thought that was me. Did we collide in the sign up?
Oh, that'd be interesting.
Yeah, that actually, that's the detail page in the portal. That's not the actual link. So something that seems like the fields. So that comes from here. So this endpoint is the one that's in there. So this is the modified index. Sample data 20280. Okay, this should be an easy one to find because this is not a very big data set. So it's in the survey 202. Of course, that's the one that has 178 of the results. Yeah. Oh, hey, it's this one here. Okay. Ends in BA6A5. Okay, so you went here, I assume, and then you clicked this link.
I clicked the transfer/sync.
Oh, you clicked that one.
But I wasn't seeing quite that much metadata either. Maybe there is something that I skipped. Yeah, where it says complete metadata, there's nothing on mine.
Okay. So then somewhere you're either you didn't do this. You didn't update this file, which gets the metadata out of the index, or something isn't mapped in this file. Actually, this gets the metadata is set here. I can see you're getting the right endpoint. This is where that's coming from, although it's also in the meta. Yeah. Yeah, because this is the exact same data set that I'm getting here. And you can see that the link is different. So I think you might not have updated the template, perhaps. I'm not sure, or the fields, one of the two. Because this is where that Globus app link gets. If you look at your fields.py, make sure that it looks like this. Or in fact, it needs to look like this entire file. But this in particular is the little function that generates that link that's put behind this transfer sync button.
Okay.
And it has to actually use this endpoint ID. I've hard coded in here. This is not ideal. I mean, this is the kind of stuff where these IDs and things should be in settings files, but this was just by way of trying to keep the number of files that are modified to a minimum.
Yeah, I think I might have missed that file entirely as something I needed to change.
Yeah, that would also explain why you don't have metadata potentially. Yeah.
Yeah.
Because the facets will show up if you just update this, but then there'll be no data because this is where the data comes from, the metadata.
Where is that file located?
This file is in, it's 2 levels down. It's inside your, oops.
Is it in components?
No, it's just, it's here. So in my case, I used SGVAS for this. Yeah, Yeah, it's not in the top level there. It's one down in whatever you called your slug, your project slug.
And where is the code that you're supposed to put into it?
It's in this file, fields.py. So where's the replacement code? It's in the repo in go to the code here, tutorials.
Fields.py.
Fields.py, yeah. So it's just literally just copy paste that entire, replace the text with this file.
Okay.
If there's nothing else, I appreciate everybody joining us. Thank you. And any questions? So we will have the slides posted on that link, and I'm sure it'll be available through the conference machinery somewhere. And you're more than welcome to reach out to us directly, Vas at Globus, L. Liming at Globus, Steve Turoski at Globus. Yeah.
Yes,
okay. I think it's just Turoski at Globus. Yeah.
Thank you very much. It's a great tutorial, and there's more conference tomorrow at 11 Eastern. So everybody come back refreshed.
Okay. Bye, everybody. Thank you.